Hey guys, and welcome back to another video tutorial. Today I'm going to be going over a reinforced concrete beam support with two supports and one impactor. And we're going to be doing this analysis in Explicit Dynamics, which is a high-speed analysis solver. So this is actually not going to be a slow compression test of the beam, but rather a impact of the concrete beam with reinforcement. So as you can see here, if I click on this and hide this concrete, you can see the inside I have these line bodies, and these line bodies are actually going to be my reinforcement. If I click on the mesh, you can see them here pretty clearly. So that's the analysis that we're going to be doing today, and I'm just going to go over a little bit about what Explicit Dynamics is. It's a high-speed solver, so really it's for high-impact problems. So as you can see here, the impact velocity is over 50, 1,000 meters per second. We're going to be using the explicit solver, which is different than the implicit solver, which is the static structural that we've been normally using. So in this case, we're going to be using this module here, which is the Explicit Dynamics. So just some other things that I could show you, like why use explicit. This is like drop tests, bird impact tests. So this is just an example of it, and just so you know, the time steps for this solver are extremely small. That's due to the because basically because it's an implicit solver, it goes based on the material sound speed. So it's directly proportional to the size of your mesh. So the higher mesh count you have, a lot slower, it'll take a lot longer to solve. So as you can see here, the time step is a function of the characteristic length over the speed of sound of the material. And here as an example, it takes about 500,000 time steps to run 0.1 seconds. So if you have a slow, if you want to do a slow simulation, well, you're obviously better off with your static structural. Now I'm going to be doing another concrete beam video in static structural, so a low impact or just basically a compression test of the beam, but it's slightly more complicated, and so that's why I figured I'd start with the Explicit Dynamics version of this problem to give you guys. So basically, to start off, I'm going to actually be giving you this geometry file for you, so you can go ahead and download that in the description below at the end of the video, and you'll have that for you, so you don't have to make this model yourself. But just to get started, I'm going to actually show you a demo model on how to make, let's say, a body with some reinforcement bar, and then I'm going to delete that model, and then I'm going to just import this one here and continue with the tutorial. So what you're going to want to do is you're going to want to basically either drag in or double click Explicit Dynamics, and it will basically load it into your project schematic. We're going to go ahead and rename this to Explicit Dynamics of RC Beam, and then we're going to hit enter. Next, what we're going to want to do is you're going to want to save your project. So hit File and Save As. I already have this thing saved, so I'm going to hit Save My Project. Next, we're going to go ahead into Engineering Data, and we're going to want to basically load in engineering data sources. So go ahead and click there. Double click on Explicit Materials because we're using the explicit solver, and then basically scroll down until you find concrete 35 megapascal. And the source for this reference is given here, and this is a good base. You could basically use this as a starting point, and if you have your own concrete properties, you can go ahead and enter them here, and you can change your concrete properties there. So we're going to go ahead and use the default one that's given by ANSYS in the library, and we're going to go ahead and add this to our project. So we're going to click on this yellow button here to add it to our project. Next, we're going to uncheck data sources. And as you can see now, we have two materials for our project. We have the concrete and we have structural steel. So the structural steel, we're going to keep that. We're going to use that for our reinforcement bar, and the concrete obviously for the concrete block. Then we're going to go ahead and close this, hit save again. Now we're going to open up geometry. So normally what I would do is I would import the RC beam file, but in this case I just want to show you guys quickly before I get started with the full tutorial on how to maybe make a block with a line body and a reinforcement. So if you want to do this on your own later on, you can. So double click on the XY plane, go ahead and click on this to be normal to it, click sketching, and we're going to want to insert some grids. So we're going to hit the grid here, go back to draw, click on a rectangle, and we're going to zoom in a little bit here, and we're going to draw just a quick body. This is just a quick example. You guys don't have to do this right now if you don't want to. It's just to give you an idea of how you would go about it if somebody wanted to make their own block. So then you go ahead and hit extrude, hit apply because it already selects the sketch, and then we're going to go ahead and add frozen, which will separate these bodies instead of joining them together, and we're going to add 4 meters in depth. So there we go, there's our small demo. And next what we're going to want to do is we're going to add rebar in the middle of this block. So what we're going to do now is click with the face selector, click this face, click on new coordinate system, and then here we're going to offset this using the transform on the Z, and we're going to offset the Z by -2 meters. So we're going to put this plane right in between this block, hit generate. So now we have a sketch plane, or a coordinate system rather, that's in between the depth of the block. We can go ahead and click on the Z here, which will make us normal to it. Then we can go ahead and click on the plane, click sketching, and then we're going to use our grids again just for simplicity, hit draw, and we're going to draw just 4 points. One here, another one there, another one there. Now to create the line, we go concept lines from points, select this point, hold control, select this point, and then hit apply. And then we're going to do generate to generate the line. Then we're going to do again lines from points, click this one, apply, and then generate. So now as you can see, we have our 2 line bodies highlighted in green. And now if you go ahead and click on these solid bodies, we can see that, well, the line body needs a cross section. So it needs to have a cross section defined. So what we're going to do is go concept, cross section. Here you can choose your own cross section for your rebar. Most of the time it's circular, so I'm going to hit circular. And then here you define the cross section radius, so I'm going to put 0.05 meters. And then now we can go back to our line bodies, hold control, select both of them, and select here the circular cross section. So now we have a fully defined 4 blocks with 2 line bodies with a circular cross section defined. So we can go ahead and save. And now once that's saved, we can go ahead and open up the model. So this is going to say here at the bottom, starting mechanical. So that's it, we're loading up the model here. And so that's it, attach completed. And now we have our model here, and we can go ahead and just right click and generate a quick mesh. Perfect, so now we have a quick mesh generated. If I click on this and hide this body, you can see here, that's our rebar. It actually looks a little bit thin. We could have made it a bit bigger. So you can go ahead into the geometry modeler here, and you can go ahead and change this circular cross section to, maybe 0.1 meters or something, and that would update it. You can go ahead, right click and update it from source. That will update your the size. So there we go. That's a quick mesh. That's a quick of how you would get it in here, and then next you would go and change this block to concrete. So that's just quickly how to make this geometry. But what I don't want to use this geometry. I want to use the one that I showed you earlier. So I'm going to go ahead and close Design Modeler, minimize Mechanical, and I'm going to right click on Geometry here, and I'm going to do Replace. And I'm going to choose, you guys go ahead and click on Browse, and browse for the RC Beam file, which is going to be in the description below. You can go ahead and download that. It's going to be called rcbeam.agdb. So you would hit Browse, and you would browse for that file. I already have it saved here, so I'm going to click on that. And then it says here now to update. So I'm going to go back into here. I'm going to right click on my geometry and update geometry from source. So now it's going to basically use the model that I was initially wanted to show you guys, which is this model here. So we're just going to let that load. That's loaded up. Nice. So here we go. Next, what we're going to do is, again, like I said, for the concrete, we're going to want to change the assignment to concrete 35. The rest, we're going to have all these line bodies. It's going to be the structural steel, and the supports are going to be made out of steel, and the punch we'll leave it as steel. Next, in the connections, Explicit Dynamics automatically creates the connections for you, but because we actually don't need them because we have body interactions in Explicit Dynamics. So I'm going to go ahead and we're going to delete the contacts folder. So we're just going to keep the body interactions. And body interactions means that any body that touches another body, it will detect it automatically and it will come into contact. And here we have it as frictionless. You could change that to frictional, but we're going to keep it for frictionless in order to speed up the runtime. Now the other thing that we have to do in the connections is we have to connect the reinforcement to the concrete. So in order to do that, we have to right-click on body interactions, insert a new one, and here we're going to change the type to reinforcement. And this is actually meant for this kind of thing. It's basically if you have a body inside another body, you want to reinforce it. So it's basically the line bodies inside the concrete will act as a reinforcement. So we're gonna rename this to reinforcement. So then that's done. So we have our body interactions, which will basically do the contacts between all these points here, and we have a reinforcement interaction, which will be the rebar inside the concrete to reinforce it. Next, what we're going to do is click on the mesh, click on sizing, and for the element size, I just want to make sure that we're all in millimeters here, and we're going to change the element size to 15 millimeters. Hit enter, and then right click and then generate a mesh. Now, actually, for the meshing and for the solving, you also want to make sure that you have the maximum number of cores enabled. So just click on, I might have did that too quick, Tools, Solve Process Settings, My Computer, Advanced, and make sure that you have your maximum number of cores. So if you have 4 cores, you set that to 4. If you have 2, 2. If you have a GPU, you can also enable that as well. And I also have it on Distribute Solution if possible. And also for the meshing, you can use parallel meshing. So you can go into the options and go into meshing, and then here you can set, number of CPUs for parallel meshing. I actually don't have this on. So I'm going to go here and put that to 4. And then here I'm going to put that number of CPUs for meshing methods. I'm going to put that to 4 and hit apply. So it's just going to mesh faster. So now we have our mesh already done. Element size of 15. We can go ahead into the Explicit Dynamics. So we're going to just minimize this, minimize the connections. So now what we need here is we're going to add in the initial conditions, we're going to right click and add a velocity. Using the body selector, we'll select the punch here and hit apply. And then instead of vector, we're going to use components, and we're going to use 8,000 millimeters per second in the Y direction, which is 8 meters per second this way. So it's going to basically hit this concrete block at 8 meters per second. Next, in the analysis settings, what we're going to do is we're going to choose an end time of 5e to the minus 3, and then hit enter. So that's going to be our end time. As you know, the time steps are extremely small, so that's why the end time is so short. And then we're going to need to add a fixed support. So right click here, insert, fixed support. And using the face selector, we'll select this and hold control, select this, and then hit apply. So these two should be blue. So that's a fixed support underneath, so that's not going to move. And then next off, we're going to go back into the analysis settings, and we want, in the erosion controls, we want the elements to delete themselves when they fail. So we're going to go ahead and click yes on material failure. You can go ahead and rerun this yourself and click using no and see the different results. In the output controls, we're going to go ahead and change this result number to 50 to get a bit higher quality number of result points at the end. And that's about it. And then once you have all that done, we can go ahead into the solution, right click, and let's say select total deformation, and then we can go ahead and solve. Now I'll solve it right now, but I'm not going to wait for it to solve because it's going to take too long for this video. But basically it's going to go ahead and solve right now. And in the solution information, you'll see that it's going to start up, and it'll give you an estimated time to complete the problem. So it says here license acquired, finished model setup. So now here it says the progress, and as you can see here, on my machine it's going to take about 7 minutes to complete. So I'm not going to wait for that to complete. I already have a completed model, so I'm going to stop this, and I'm going to go back into my completed model, which is here. So this is the total deformation results that you should see. I actually might have a bit of a higher mesh in this one. I think I used 12 millimeters, so this might be a bit more refined than yours. So this is the results for the deformation. You can go ahead and change the scale. So if you wanted a 5x or a 2x, oops, I didn't wait for that to load, 5 times deformation, so that would be a 5 times. and 2 times the actual deformation scale. So as you can see here, this is the results. You can right click on the legend here and adjust to visible. It might give you a better, it might readjust the colors. You can go ahead and click on this play button, which would animate the deformation. But the one that I want to show you the most, and the most important one, is the damage. So basically, which elements have been damaged. So what I'm going to do is I already have that here, but I'm going to show you how to get that. So I'm going to delete this. You click on Solution, click on Worksheet, and these are all the possible, basically all the possible solution quantities that you can get using this analysis. So you can go ahead into the damage, and you can go ahead, right-click, and create a user-defined result. Then you can go here, right-click, and then evaluate that result. So this is the damage. So basically, 1 means that the element has failed, 0 means it's completely intact. So as you can see here, the ones, there's no red because the red is all gone. But I could actually change the scale a little bit just to give you a better idea. I'm just gonna adjust to visible. And as you can see now, you get a bit more red here. So the elements here have failed, and I can go ahead and change the scale a little bit to show you a little bit better. So these are all the damaged cells. So that's basically it. I have a video that I show you. If you hit the play button here, you want to make sure that you're on the results set option here, and you should have 50 frames. Here I have 100 frames because I changed it in the analysis settings here. I used for the output controls, I use 100, but you guys should have 50 here. You can go ahead and hit play, and you can save the video as well. And I have a video already done, which I'm going to bring in right now. Where's a VLC player? So this is it, and I'm going to show you the video right here. So there we go. If you hit play, that's what you're going to see. So it's an animation, basically the concrete impactor hitting the block, and you can see the elements as they get damaged. So I can go ahead and loop that, and there we go. So this is actually, I think it's at 3 times the deformation scale, but that just basically shows you all the elements that get damaged. You can see here some of these elements are just about to break. If you increase the velocity, you would probably get that effect. So there we go. That's the damage function. And what else did I want to say? Oh yeah, we can also show you the deformation of the rebar. So what we're going to do is we're going to hide this, hold control, and I'm going to select, using the body selector, I'm going to hide all of these bodies. And now I'm going to actually use a box select, line edge tool, select all of these, and then I'm going to right click, insert deformation, and I'm going to use, I guess, total deformation, and then I'm going to evaluate the results. So there we go. So as you can see here, that's the total deformation of the rebar, and as you would expect, it would be a lot deformed here, and these are due to the supports. You don't really see the other bodies in this thing here because we just selected the edges. But if you were to, I guess, run an animation, I hope it won't take too long to set up. If it does, then maybe I'll just go ahead and stop it, but we'll see. So just going to wait for this animation to begin loading. I think it's going to take too much time on my machine, so I'm just going to actually leave that at that point. Oh, there we go. There we go. So there we go. It basically, that's, I think we'll, it's loading each frame right now. This is exaggerated 78 times, which is a really, I think is a way too much. We should have been a lot less than that, but no worries. So this will just, everything is freezing here. It's just because it's loading each frame. I have 100 frames. I should have maybe put less, but it's basically going to give you an animation of how the rebar is deforming inside the concrete. Now, basically, you can, so like I said, you could also try this without the material failure on. So in the analysis settings, you can go and turn that off and see what you get there. Also, like I said before, I'm eventually going to post a video on a static structural version of this. So basically, you know, do I have it? No, this thing wasn't solved. So basically a static structural version of this, which will basically be using the static structural module I'm going to be using. And that's about it. And the other thing that I wanted to mention is in the solution, you want to also keep your hourglass energy relatively low. If I open up this module here, solver output, energy conservation, here you have, this is the, I didn't solve this one yet, but you have your momentum summary, and you have also your energy summary. So this hourglass, there's a red line here. You always want to keep that low. If your hourglass energy is high, it might be that you have some invalid results. So anyway, so that's about it. This is just going to keep loading. I shouldn't have done that. I didn't realize that it was going to take this long, but that's about it. So that's the that's basically all I have to show you today. And if you guys enjoyed the video tutorial, please subscribe, because you know, basically it gives me the drive to give you guys more videos. And if you liked it, also please like, and feel free to ask any questions if you have any in the description below. So anyway, thanks for watching, and I hope that was helpful. So see you next time.